This is a follow-up video on cutting unsintered ceramic materials with a model 204 Heavy. It's proven to be a more challenging material than we had first appreciated. The material at the very last bit of the cut likes to fail. Here's the worst case example of what can happen. So the machine cut all the way smoothly through, in the last little bit the material broke instead of cutting. There's a couple of factors going into this. The first problem relates to how bandsaws work. This is a bandsaw blade, very similar to what we're using on the saw right now. It's a carbide grit edge blade with gullets, so the grooves between the teeth are called gullets, help clear the dust. Bandsaw blades, to cut, have to push down into the material. If you just rest the bandsaw blade on there and pull it across, you're not cutting anything, at least not in a human lifetime. In order to make a cut, you have to push down onto the blade as it moves across the workpiece. In rough terms, the harder you push, the faster you can get the blade to cut through the workpiece. This is fine when you're in the body of the material, but it's a problem when you're cutting through and just about to break out of the workpiece. You've got a little sliver of material remaining, and the blade is pushing against that material, and it wants to pop it out. We've seen this in various forms. On this workpiece, we were cutting quite quickly, so the blade had to push into the workpiece pretty aggressively. And you can probably see the striations on the workpiece showing where the blade was. You got to this last little bit and it popped out half an inch of material. This is a similar case, a little bit slower. See if you can see the striations here. The blade was coming this way, hit that last little bit of blade's coming across here, cutting. It's actually a vertical blade saw, so it's like this. Blade's coming across, cutting, gets that last bit of material, pop. So we tried going very slow. When we go very, very slow, we get just a tiny little divot. But of course, everybody wants production speed. So they want to go fast. We can get around this somewhat by, when we're here cutting fast, when we get to the end, slow down. We have another problem though. This material is not a nice clean cylinder. It's bumpy. And it can be the case that if you have a high point on this side, a high point on this side, you're really only supported on 2 points. You're supported on a point here and one over there, and it's bridging in the middle. So when you cut through, it's been bridging across, you cut through, the material wants to fall in, boop, like that. And that can lead to the workpiece breaking. Something else we've just discovered, I'll zoom in on this so you can see. This particular workpiece, as I have right here, got a high spot under here, a high spot under here, so it's basically sitting on a point right here and right here. This is a very heavy, dense material. It also has no elasticity, it's very brittle. So because it was sitting on a point right here, the weight was concentrated on a small point, just the weight of the workpiece crushed the material a little bit here. Just as we set it very gingerly, I would say, set it down, all that weight on one small point crush the workpiece. So we got a little flaw right there. This material is challenging to cut. This may actually be better suited to a vertical application than to a horizontal application than a vertical. The difficulty with a vertical or horizontal saw application, though, is if you have a tall, skinny workpiece, now you're trying to cut at the top of a very spindly, unstable workpiece. But for the vertical saw, we can get there. We've made several successful cuts. The short version is you need to go very slow at the end. I'll go ahead and knock off a 1/2 inch piece here. I'll go a little more aggressively in the middle, and I'll slow down to just about nothing as we reach the breakout point. Zoom this back out for you a little bit. Okay, we'll start up the blade motor. Dust collection, please. I'm going to start off the table drive at a very slow speed. Once I'm in the body of the material, I'll speed up, and as I get to the very exit, I'll slow back down. The blade is well engaged in the workpiece now. Speed it up a bit. As we've discussed before, evacuating the dust from the center of the cut, kind of a pain. Down a little bit. I'll let the workpiece get to about here, and then I'll slow it down to a very slow crawl. This right now is much slower than we can cut this material and still get a good surface finish. The surface finish we're getting is very good. The difficulty lies in keeping from fracturing the workpiece. Back the table drive down to a much slower speed now. moving. It's just this machine has the ability to run very slow. Shut it down instead of waiting for it to shut itself off. So here's the breakout point. You can see the color and nature of the cut changed a bit as I slowed down to that super creepy slow speed. But I got no breakout effect. And the cut edge here is just about perfect by going slow. Matching component. So if we babysit the cut, we can get a very nice cut. Usually we can be a little bit more automatic than that, but this material is challenging. You can see here, the prior cut, that's where it crushed the corner. That's where it was, so the workpiece was sitting like this. It was sitting on effectively a point there, and that crush caused that. That's just the weight of the material sitting on its own surface. It might be more desirable to sit it horizontally unless you have a very tall, skinny workpiece, in which case a vertical saw is a better choice. It's a challenge.